Let's discuss the proper method for derating multiple current-carrying conductors in a single conduit. The question we're addressing is, how do you correctly derate conductors in a conduit? And how do you determine the correct conductor sizes, considering both the breaker rating and the ampacity of the conductors? The procedure involves several steps. First, you need to determine the ampacity of the conductors. You'll find this information in the National Electrical Code, specifically Table 310.16. This table provides ampacity values based on the conductor type, its size, the insulation material, and the ambient temperature it's designed to handle. Second, you need to adjust for ambient temperature if it exceeds 30 degrees Celsius. If the surrounding temperature is higher, the conductors can't dissipate heat as effectively, and their ampacity is reduced. Apply correction factors found in NEC Table 310.15b to adjust the ampacity values you found in the first step. Third, you need to account for the number of current-carrying conductors in the conduit. When multiple conductors are bundled together, they heat each other up, reducing their individual ampacity. Determine the number of current-carrying conductors in the conduit. Then apply the appropriate correction factor from NEC Table 310.15b3 to each conductor's ampacity value after it's been adjusted for ambient temperature. A neutral conductor that only carries the unbalanced load from other conductors is not considered a current-carrying conductor for derating purposes. Fourth, you should determine the overall ampacity of the conduit. Add up the derated ampacity values of all the conductors in the conduit. This sum provides the maximum safe current the conduit can handle, given the conductor sizes, temperature, and number of conductors. Fifth, and finally, you compare the overall ampacity of the conduit to both the breaker rating and the ampacity of the individual conductors before derating. The actual current demand on the circuit must never exceed the lowest of the three values. Those values are 1. The breaker rating, 2. The overall ampacity of the conduit after derating, 3. The ampacity of the individual conductors before derating. The breaker rating may be higher than the ampacity of the conductors or the overall ampacity of the conduit after derating. This is acceptable as long as all other conditions are met. If the actual current demand exceeds any of these three values, larger conductors or a higher rated breaker may be required to ensure safe and reliable operation.